Okay, very good morning to all. So today topic high voltage engineering, class 3, chapter 1. So in the previous sessions, we are learn the dielectric materials, high voltages, voltage levels. Okay, that we have discussed in the previous class. Now we are going to go to the chapter 1. Okay, so what are the topics we having? The topic 1 we are having the breakdown in gases. Okay, how breakdowns take places in the chapter 1 that we are going to discuss in the right now. Here, so for breakdown that process, so what is the ionization process? Okay, how it will be like. So breakdown of gases in the high voltage engineering equipments. Okay, how it is happen, that will be discussed right now. Okay, I hope all of you seeing the slide, right? So date 31st. Okay, good. So here in the high voltage engineering, we are having the first chapter, yeah, breakdown in gases. In that, ionization process, deionization process, okay, thousands theory, okay, and other factors will having. So first we are going to learn the what is ionization process. Okay, so here in the ionization process, nothing but it is whenever we applying the high voltage on the gas material, if it is become the conductive material, that is nothing but a ionization. Okay, that is ionization. So here, so here's nothing but if it is a high voltage equipment material, okay, in that, and so here we having the anode cathode plates of the equipment. So suppose positive negative or anode cathode metal, if it is in between, if this gas is filled in between, okay, if we applied the high voltage in between anode and cathode, so what will happen? So it will have to stop the whatever the gas is, that will have to stop the flow of current. Okay, if it is that atoms is failed, okay, if it is that atoms are failed to whatever the voltage that applied, okay, then it is have to act as an insulator. We If it is act as a conductive material, that means it is due to the cause of the high voltage, so that process called as a ionization method. Okay, so it's nothing but ionization process, nothing but applying the high voltage on the gas and it became the conductive material, then the property of the material will be spoiled. Okay, that process known as a ionization process. Here in the ionization process, here to state the ionization process, we are having the thousands theory and or streamer theory. Okay, thousands is a scientist who are in some inventions. Okay, some theories were discovered based on the how ionization process take places. Here we are having the two types of ionization process. One is primary ionization and secondary ionization. So that will be divided into two types, primary and second. In the primary, again it's divided into three types: impact ionization or collision ionization, photo ionization. Okay, so impact or collision ionization, photo ionization. So in that, first we'll discuss about the impact and photoionization. In the secondary ionization, okay, the secondary ionization we have the electron emission due to positive ion impact, electron emission due to metastable neutral atoms, thermionic emission, thermal ionization, field emission. Okay, another method is so electron attachment or recombination, diffusion or mobility method ionization. So first we'll discuss about the what is primary ionization or collision ionization. Okay. Okay. First we see we're having the anode and cathode material. These are the two metallic plates. if in case if take the high voltage engineering, so these are the two electrodes which having filled in between the gas. So here cathode refers to the negative and anode goes to the positive. Okay, here in this one, when it is filled with the gas, so in the gas metal which having the gas metal which having this one, so in this one what will happen, so here gas material will be there. So the whatever the gas material is there, okay, that gas material it forms the, so this whatever this is there, so it will having the gas. So whenever the high voltage is applied, okay, so whenever the high voltage is applied, what will happen, the electrons, so whatever the electrons is there, okay, so whatever the electrons is there, that will collide with the atoms. Okay, so whatever the electrons is there, so from cathode to anode, anode to cathode, so here we have the electrons, so we are having the gas electrons is there. Okay, so due to the current flowing in the high voltage in the gas, so what will happen, it will emission the electrons, okay, and as well as ion. So ionization, so ions, positive ions also develop. So in this case, so due to colliding with the electrons in the ions in the gas, so it causes the emission of the electrons and positive ions. Okay, so due to that, here so here we are having the gas. In this gas, so we are providing the by conductors, whatever the metallic conductors are, that we are going to give in the high voltage. So here in this one we are having the gas. So due to the high volt flowing into the gas, so whatever the electrons is there, okay, that is collide with the ions, okay, positive ions, and it will developing the electrons. Okay, that electron causes the flowing of current in this gas. Okay, that electron causes the flowing of current in this gas. So here if it's flowing of electrons in this gas cause a current flow, so it may cause the breakdown of the gas. Okay, this process is known as the ionization by collision. Okay, so whenever the gas is there, okay, here we're having the gas, that gas having the applied by the high voltage, so that due to that, so ions, whatever the ions is there, and electrons in the gas, that collide each other, and if the providing the generation of the free electron, that free electron causes the current flow in this gas. Due to that, the whatever the material is there, okay, that will causes the current flow in this gas. Okay, that process known as the ionization by collision. So I will, so in this process we are into that, so ionization by collision. So here whatever the materials, okay, at the out at what limit it will be generate the current, okay, at what limit will be goes to like this, so it will be, so whatever the is there, okay, if it is material, so whatever the gas material, so what that will having the mu, okay, so permeability method, okay, whatever the dielectric strength is there, that dielectric strength will having the above, okay, greater than the potential barrier, okay, what is the potential barrier, that will be having the greater than, then only it will have the pass. Okay, this process is will be happens. Now coming to the photoionization. In the photoionization, so in the photoionization what will happen, so whenever we having the two cathodes, okay, sorry, one anode and cathode, and two metallic plates, in the cathode having the negative side and the anode having the positive side. Here we'll having the giving the high voltage, and we'll having the gas in between, and here we are giving the one current limit for this one, and in this one, so whenever the water the current is that will flowing through like this. So here due to that, so here we are providing the high voltage, and whenever the photoelectrons is, okay, we are providing with the ultra UV rays. So whenever the UV rays flows on the in this gas, okay, what will happen at this stage? So whatever the gas is there, that will provide generating the electrons, okay, that generating the electron, that electrons causes the current in this gas, okay, that electron causes the current in this gas. So due to that, it will goes to breakdown. This process known as a photoionization process, okay, this process known as a photoionization. So whenever having the, so we are having the, we are giving the UV rays, okay, we are giving the UV ray. So we are having the cathode, anode, and here we are generating giving the high voltage current. So high voltage we are applying in this one. So whatever this is that, here gas is there, okay, and we are providing the UV rays on this gas. So due to that, UV rays fall down on this gas material, it causes the electrons production in this gas. This causes the collision, okay, due to that the current will be flowing in this gas. So this process known as a photon. So without photo, okay, if it is, we did not give the any rays, okay, so at that time what will happen, there is no electrons production, okay, that if it is due to the UV rays, it causes the electrons generation in this gas. That process known as a photoionization. So here in this way current will be flowed. So in normal stage it will be act as a dielectric. So whenever the photo is take places, it will act as a current flow in this one, okay. This is the photoionization process. Here coming to the secondary ionization process, okay. In the secondary ionization process, what will happen? So in the secondary ionization process, we will having the whenever the collisions take place, okay, so it is whatever the material is there, okay, due to the collision ionization, so whatever the free electrons is providing, okay, so here we are having the cathode and anode, right? Here we in between we are having the gas, and we are giving the, so we are providing the high voltage. Here we are having the gas, okay, here we are having the gas. So whatever the gas is there, we are providing the high voltage. So here it will act as a insulating medium or dielectric medium. So whenever the current is there, okay, if it is increasing the high voltages, okay, with the beyond of the whatever the strength is there, okay, mu r, okay, above potential barrier we are increasing the voltage, okay. So that time what happens, it will generate the electrons, okay, it will generate the free electron that. So whatever the free electrons is, it will also produce. So that is a collision process, okay, ionization collision. So due to the ionization collision, so whatever the ions is it, okay, ion positive ions also produce. So that positive ions, okay, whatever develop in this anode, okay, so positive ions is flows toward the cathode, okay, and free electrons flows toward the anode. Due to that, so whatever the positive ions say, that will collide with the cathode. Due to that, the here collide with the cathode of the positive ion, production of the free electrons. This process known as a secondary ionization, okay, this process known as a secondary ionization. So these are the primary ionization, okay, ionization by collision, photoionization, secondary ionization, okay. Here we can see, so collision ionization is nothing but here we are having the electron, okay, we are giving the that electron. So whenever the current is high voltage is flowing through. Okay, what will happen? So it will, whatever the atom is, okay, that will collide with the electron, that causes the production of the free electrons. Okay, that production of the free electron, in this process the current will be flow. Okay, here the positive ions also produce. Okay, the positive ions also produce that ionization. Okay, so this is the primary ionization. So if it is secondary ionization, what will happen? So these free electrons that will goes to the uh, anode, right? And whatever the positive ions developed in the anode side, that will goes to the cathode side. Okay, that production causes the free electron again in the cathode. Okay, that is the secondary ionization. So we'll stop the recording now.